Okay, so here's a thought. What if a cosmic event, something that happened millions of years ago, left a hidden message buried deep in our planet's crust? And what if it points towards a totally wild, undiscovered future for us? We're about to explore a mystery that connects the dots between our deep, ancient past and our future out there, among the stars. So let's just imagine for a second that our solar system isn't this quiet, isolated island in the galaxy. Picture it more like a ship sailing through these vast cosmic seas. And what if, millions of years ago, we sailed right into a storm? I mean, a real cosmic tempest, one that left a mark, a permanent scar deep inside our own planet. Our sun doesn't just sit still. It's on this epic journey through the galaxy, and it's navigating a pretty turbulent neighborhood full of gas and dust and radiation. And what you're looking at here, this map, it shows that environment. Those hot yellow areas, they're these huge, mostly empty bubbles. But the cooler, blue regions, well, that's where things get interesting. Those are dense interstellar clouds.
Right. So the big question is, what happens when our solar system's journey takes us right through one of those dense, cool blue regions? Well, it turns out a recent study gives us a pretty direct and really fascinating answer to that.
So, researchers at Boston University are saying this is exactly what went down about 2 million years ago. I mean, think about that. While our early human ancestors were just starting to walk the Earth, our entire solar system, the whole shebang, plunged right into a massive cold interstellar cloud. Now, to really get why that's such a huge deal, you gotta know about our solar system's personal protective shield. It's called the heliosphere. And the best way to think about it is like a giant magnetic bubble, constantly being blown outwards by the sun. It wraps around all the planets, including us, and it's our main defense against all the harsh radiation flying around in deep space. And here you can see that shield in action. The heliosphere kind of acts like the bow of a ship, plowing through space. It creates this thing called the termination shock. That's the boundary, the exact point where it's pushing back against all that interstellar gas and dust. And really, this boundary is our first and most critical line of defense. But here's the thing. That cloud we ran into 2 million years ago, it was so incredibly dense, it was like our solar system hit a cosmic wall. The sheer pressure from this cloud could have literally squeezed our heliosphere, maybe shrinking it so much that for a while Earth was actually outside the bubble, completely exposed to the raw, unfiltered interstellar environment, no shield at all.
And you might be thinking, how could we possibly know that? Well, we have physical proof. It's incredible, really. Geologists have found layers of these very specific radioactive isotopes, we're talking iron-60 and plutonium-244, buried deep in ocean crust and Antarctic snow, even on the moon, all dating back to that exact time, 2 million years ago. Now, these elements are only forged in the hearts of dying stars, in supernova, so the fact that they made it all the way to Earth, well, it means our shields must have been down. So what this whole event tells us is that the edge of our solar system isn't some fixed line in the sand. Nope, it's a dynamic, shifting frontier. And understanding that frontier is absolutely crucial, which naturally brings us to our first attempts to actually go out and map this unknown territory. Right now, our only eyes and ears way out there are the legendary Voyager probes. I mean, launched back in the 70s, these things are still going. They've crossed into what's called the heliosphere. That's the really turbulent outer layer of our shield. And the data they sent back, well, it was exciting, but also really puzzling. Just look at these wild fluctuations in the magnetic field from Voyager 1. The readings just didn't line up with any of our models. They honestly raised more questions than they answered. And here's the problem. The Voyagers are, let's be honest, getting pretty old. They're running out of power. They probably won't survive long enough to reach the true edge and punch through into interstellar space. So if we want to solve the puzzles they uncovered, we're going to need a new generation of explorer. And that brings us to the future. Because, look, if we want to get answers within our lifetimes, we need a radically new and, frankly, much faster way to travel out there. So meet the proposed Interstellar Heliopause probe. This is a totally next-generation spacecraft, and it's designed with one single-minded purpose: get to the edge of our solar system and get there way, way faster than ever before. And the plan for how it's going to do this is just incredibly elegant. First, it'll unfurl this massive, paper-thin solar sail. Then, instead of flying away from the sun, it's going to dive towards it. It's going to use the intense pressure of sunlight itself to pull off something called a solar photonic assist. It's basically a gravity slingshot, but supercharged by light. This will fling it out of the solar system at just unbelievable speed. So on the left, you can see a simulation of that crazy looping path. The probe would make this super close pass by the sun, using that intense sunlight to build up crazy speed before it gets shot outwards. And on the right, that's the tech that makes it all possible. These are ultra-lightweight carbon fiber booms. They're strong enough to hold open a giant sail, but so light they can actually be pushed by particles of light. It's amazing stuff. Okay, so let's pause for a second. We have hard evidence of a cosmic cloud bumping into us in our distant past, and we have the technology on the drawing board to go explore these regions in our future. But this is where our story takes a really fascinating turn, from hard science into the realm of science fiction.
So we know for a fact these interstellar clouds are real. We've seen them. But what if we've been thinking about them all wrong? What if they aren't just random collections of dust and gas? What if they're something else entirely? Believe it or not, way back in 1957, the brilliant astrophysicist Fred Hoyle asked that exact question in his classic sci-fi novel, The Black Cloud. He had this wild idea. He imagined an interstellar cloud drifting into our solar system that wasn't just a cloud, it was a living, thinking, intelligent being. So in Hoyle's novel, this cloud actually starts communicating with scientists on Earth. And the cloud is, well, it's completely baffled. It's shocked to find intelligent life thriving on a solid planet, which it sees as a totally hostile and bizarre environment. And it basically views humanity with this sort of detached curiosity, kind of like how we might look at an interesting ant colony. And that idea, that incredible leap of imagination, is what brings our whole journey here full circle. Because it forces us to ask a really profound question about our own place in the universe. So let's put it all together. The science, it shows us we're not alone on some isolated island. We're part of a huge, dynamic galaxy that has physically shaped our planet's history. Our technology shows our deep, undeniable desire to get out there and explore it. And then fiction, stories like Hoyle's, they challenge our most basic assumption, that we're the most important thing around. Hoyle's novel really boils it down to this choice you see here. Are we the big fish in a small pond, the dominant intelligence in our own little solar system, but ultimately totally alone? Or are we willing to accept that we might be the small fish in a very, very big pond, just one tiny part of a vast, connected, and maybe even intelligent universe? So the question is, which one are we? And maybe more importantly, which one do we want to be? Maybe by finally pushing out to explore the very edge of our home, we'll start to figure out our true place in the incredible vastness beyond it.